The next topic is deadlocks. Okay, so the definition of deadlocks states that a set of processes in the deadlock state when every process in the set is waiting for an event that can be caused only by another process in the set. So let's see, there are two processes, a process set that consisting of two processes P0 and P1. Okay, then there are two resources are there. First one is printer, second one is scanner. Okay, assume that P0 is using P1 printer. Okay, P0 is using printer and it is waiting for scanner. Okay, it is waiting for scanner. P0 is waiting for scanner, but P1 is using scanner and it is waiting for printer. Okay, if you draw a weight graph, P0 is holding printer and waiting for P1 to release scanner, because P0 is holding scanner and waiting for to release printer. There is a cycle until and unless P0 gets scanner, P0 does not release printer. And until and unless P1 gets printer, P1 does not release scanner. Okay, so so let's see this particular code here. So here let's see P0 and P1. P0, first it invokes wait on printer, so printer is allocated to P0. Okay, then after time quanta, P1 invokes wait function scanner, so P1 is having scanner. Okay, but the problem here is until and unless this particular wait function is successful, okay, wait function is successful, then only it will go to next step. So where this particular signal operation is placed after entering into critical section, that is after using both printer and scanner, it release printer and scanner next. Okay, until and unless it gets scanner, it does P0 does not release printer. Until and unless P1 gets printer, P1 does not release scanner. So P0 and P1 is waiting in a circle. Is waiting in a circular. This circular wait. Okay, this circular wait, and P0 is holding a resource and waiting for other resource. Okay, waiting for other resource. Similarly, P1 is holding a resource and waiting for other resource. Now which one is hold? P1. Okay, which one is waiting for? P1 to release some process. P1 is holding some particular resource and waiting for P0 to release some particular resource. So this is a cycle. This cycle, we'll call it as deadlock, because there is no useful work is done in the system. Okay, this is called deadlock, where one process holding a resource and other process waiting for the same resource. Okay, other process is waiting for the same resource. So not only these two, if P0, P1, P2, so on up to Pn. Okay, so P0 is waiting to release P1 resources, P1 is waiting to release P2, P2 to waiting to release Pn, and finally Pn is waiting to release P0. There will be a vicious circle and no process is doing nothing. Okay, so every process is waiting for some process to release the resource. So there is no process that is ready to release the resource until and unless it gets one more resource, extra or additional resources. This problem is called deadlock. Okay, so system will be hang when the system gets to this particular deadlock state. Okay, so what are the ways to detect the deadlock, how to avoid this particular deadlock, how to prevent this deadlocks, we will see in this particular chapter. Okay, so before that we need to see some particular terms, that is resources and instances. Okay, so each their resources are categorized into two types: physical resources and logical resources. Okay, so physical resources are printers, tape drives, DVD drives, memory space, that is your RAM, ROM, and CPU cycle, that is your CPU. Okay, these are all physical resources. And logical resources are semaphores, that is binary semaphores, counting semaphores, and mutex logs, and files, the files that we are storing in your hard disk or hard drives, okay, DVD drives, etc. So what is mean by instance? What is mean by instance? See, printer is a resource, but if there are three printers, if there are three printers, we can say it as there are three printer instances are there, or three printer instances of printers are there. If there are two CPUs in a dual processor system, the number of CPUs are two. Then the resource is CPU and the instance number of instances are two. Okay, right? So any resource, there is an order. Okay, there is an order. We can use that particular resource. First, a request, we need to request for the particular resource. Second, after request is granted, if the request is granted, then we will use the resource. If the request is not granted, then we have to wait for it. But after request is granted, we can use the resource. Okay, then after the resource use is complete, suppose that a printer is there, after printing of 10 pages are completed, then we will release the resource. Okay, we will release that. First you need to request it, then after request is granted, you need to use it. Once your use is completed, then you need to release it. Okay, so what are the several system calls for this particular requesting and releasing? For devices, it is request and release. For semaphore, we have seen wait and signal. For mutex logs, it is acquire and release. For memory system calls, that we will see later, allocate and free. For files, you need to open and close system calls. Okay, so for every resource and all the process, see, system, there is in the operating system maintains a table called system table. Okay, so what this particular system table uses, it will maintain all the processes as well as resources. Okay, all the processes and resources, how many resources are there, and how many instances of resources are there, and whether that particular resource is available or not. Okay, if it is taken, that is allocated or not. If it is allocated, okay, if it is allocated, then which process has taken allocated that particular resource, and how many resources are allocated, everything is maintained in system table. Okay, right? So if the resource is not allocated, if the resource is not allocated, then that means if the resource is free, so first process which is asked or requested the particular resource will be allocated. If the resource is not available, the resource is, suppose the printer is not available, then it will be added to the process px, will be added to a waiting queue on printer, a waiting queue on printer. Okay, right? So let's see how many ways we can detect a deadlock. Okay, so before going to detect how to detect a deadlock, there are conditions that we need to condition that has to be satisfied. There are four conditions. All four conditions must be satisfied. Okay, if any one of the condition is broken, we can identify that there is no deadlock. Okay, the first condition is that mutual exclusion. Okay, so a process is executing in critical section. Okay, so no other process allowed to execute that particular code. Okay, so mutual exclusion is a fundamental property while providing the solution for critical section. So there must be a condition that the processes are executing in a mutual exclusive order. Okay, so next, hold and wait. As we have seen, there are processes which holds one particular resource. Okay, holds one particular resource and waiting for other resource. Okay, waiting for other resource, and other process is holds a resource R2 and waiting for resource R1, which is held by process P0. Okay, so this condition, that means it has to hold some resources and waiting for other resources. Okay, so next, no preemption. What is mean by no preemption? See, the process has to release the resource voluntarily Okay, release the resource voluntarily, but when the process will be release the resource, only when its execution, that means its usage of the critical section is completed. Okay, that means the process will only release the resource once the usage of the particular resource, it gets all the resources that is needed. Okay, it gets all the resources that is needed and it use all the resources, then it will release the resource. Okay, but that is until it gets all the resources, it will not release the previously acquired resources. That is no preemption. Okay, so next one is circular wait. As I told you, if p1 is waiting for p0 is waiting for p1 to release the resources, p1 is waiting for p2 to release the resources, p2 is waiting for p3 to release the resources, and p3 is waiting for p0 is to waiting to release the resources, then there is a circular wait. Okay, then there is a circular wait. All these four conditions must be satisfied, then we can confirm that that particular system is in deadlock state. If any one of the condition is broken, okay, then the system is out of deadlock. We can confirm the system is out of the deadlock. Okay, so let's see resource allocation graph. Okay, so it is a graph that consisting of set of vertices and edges, where the vertices are divided into two parts, processes and resources. So processes are represented in ovals and resources are represented in rectangles, and each resource, if there are multiple instances are there, each instance is represented with dots. Okay, so edges also we can divide it into two edges. First one is request edge, second one is assignment edge. Request edge means pi to ri. Okay, pi to ri, this means that pi request rj. Okay, pi request rj. Okay, before using we need to request it. Okay, once it is allocated, then it is called as assignment edge, where rj implies pi. Rj implies pi. Okay, that is rj is allocated to pi. Okay, now if you look at this particular thing, you can see that pi is, this is a request edge. Okay, this is a request edge. Pi is requesting r1, r1 is allocated to p2. Okay, but the problem with resource allocation graph, here if we in resource identification allocation graph, there is a condition that if you find a cycle, then there is a deadlock. If we find a cycle, then there is a deadlock. Okay, but it is suitable for only one resource with one instance. Okay, if a resource with multiple instance and that particular resource with multiple instance and it has a cycle, then we cannot confirm that that particular graph uh, with cycle, that particular graph with cycle is a deadlock. Okay, we cannot confirm that that particular graph with a cycle is a deadlock. That means that if a resource, okay, and with one instance, and if you found a cycle, then the system is in deadlock state. Okay, but if there is a resource and with multiple instances and there is a cycle, there may be a deadlock or may not be a deadlock. Okay, we cannot give guarantee with the system with resources with multiple instances and a cycle. We cannot give guarantee that the system is in deadlock state. Okay, so how this the implementation will be, how this will be done, we'll see examples in next video.